Okay, welcome to our next video on complicated relationships with x's. So in this one, we're gonna try and rearrange the formula. Like we said in the previous video, the problem is sometimes we try to brute force these answers just by guessing numbers and then thinking what will work. So in this case, it'll be quick to get there. I mean, 1 times 1 is 1 plus 3 is not going to be 12. So 2 times 2 is 4 times 3. That's not going to work. 3 times 3 is 9 plus 3 is. So we know the answer is 3, but we had to guess a couple of numbers to get there. And like I said earlier, that is the problem with the guessing game, because as soon as we get to very complicated relationships or equations where we have decimals and weird numbers, then suddenly guessing doesn't work. So if I made this 12.5, you would have been like, and then, that would just be too difficult to figure out mentally. Well, for some of us. Well, that would be me as well. I wouldn't know. But anyway, so we have to rearrange this formula in a specific way, and it's kind of doing and the undoing. So how do we undo plus? And that's basically just by minusing, right? So I know this x is being added, but it's not just x on its own, it's x squared. So I have to minus the 3 on both sides. And then these would cancel out. And on this side, I'd be left with x squared. And this side would be 9. And from here, again, it's the problem is it's so easy to just know the answer. But what did we do to get the answer? How do we undo this relationship? X has some kind of relationship with this little 2, and it's being squared. So how do I undo that relationship? Well, I have to get the square root, because this and this would cancel each other out. And I would do the same on the one side that I did on the other side. And then I know this 2 and this square root sign would cancel each other out, and I'd be left with x. And here I know well, it's going to be 3. I don't know how far you are in the syllabus yet, but it should be plus or minus 3, because plus 3 squared is 9, and negative 3 squared is 9, because a negative times a negative is a positive, and 3 times 3 is 9. So we actually have two answers in this case. It just depends on what math we're doing. If we're working with like distances and stuff, we're not really going to care about the minus sign, because we don't measure negative numbers. But when we do graphs and things like that later on, this negative is actually very important for us. So we should know that we always have two answers in this case. But the point is, I didn't just guess. I took it apart step by step by step. So let's take a look at another example of a complicated, let's say, equation. It's not extremely complicated, but again, guessing is not going to be our number one, option here. We have to take it apart step by step, and I have to say, what is being done with this x? There's two things being done. First, we're taking the square root of the x, and then we're also dividing it by 4. And if I told you x is 5, you'd probably, okay, let's not make it 5, let's make it 16. Let's say if I told you x was 16, then the first thing you would do is you take the square root, of 16, which is 4, and then after that you would divide by 4. Okay, obviously that would just be 1 and not 3, but the point is, you would first do this and then do that. And because we're doing the opposite, we have to even go the opposite process. So usually the giveaway in this situation is, because it's an equation and it's a fraction, I don't like fractions. I know I can get the fraction gone quickly. So how do I undo the fraction? I multiply by 4. I can put 4 over 1, maybe it's easier for it to see, but I have to do it on both sides. And I know this and this would cancel, it would reduce to 1, and what I'm left with is the square root of x is 3 times 4 is 12. And again, yes, I know that you might know the answer already, but how do I undo what's being done? So what's the opposite or the inverse of square rooting? Well, that would be squaring, because that is the opposite. So that would be squaring on both sides, because whatever I do on one side, I have to do on the other side. And I know the square root and the square is going to cancel each other out. And I'll show you why in just a bit, because I know you want to know. And then 12 times 12 is 144. So this is kind of the process that we have to follow. We have to think what is being done with the x, and then step by step undo those things. Just as a little bonus, you must have seen the indices video right now. So if you haven't, then there's a series on indices. But x, the square root of x, can be written as x to the power of a half. So these two things are the same. So if I wrote this as x to the power of a half and all to the power of 2, your indice rule would tell you if I had this, a to the power of 2 to the power of 3, that would be a to the power of 2 times 3, which is 6. And in this case, what is a half times 2? It's 1. So it's x to the power of 1, which is just x. Okay, so that's kind of the indice way of writing this. If we had a cube root here, then that would be a third, and then we'd have to take the cube, well, we'd have to cube it to undo a cube root. But okay, next video, more complicated relationships.